Greetings, everyone. All right, I'm going to go through free response question number 3 from the 2018 AP Calculus exam, and it was on both the AB and the BC exams. So let's take a look. First of all, here's the question, and ideally you would pause the video right now and try to solve this on your own, so that when you hear my explanation, you can see where you went right, where you went wrong, how you can improve, how you can change your way of thinking about the problem so you can be more successful next time. If you weren't successful the first time, so you ought to see if you can be successful the first time. So it'd be ideal for you to pause the video right now and then come back. All right, let's take a look here. It says the graph of the continuous function g, the derivative of the function f, is shown above. They like to do this. They like to give you the graph of a derivative of some function. And since right now they're telling us that the derivative of f is g is what we're looking at, I'm going to note that over here so that I don't forget it as I work through the rest of the problem. The function g is piecewise linear from -5 to 3, including the -5 but not including the 3. The 3 is the transition point between the line and the parabola, and they want 3 to be associated with the parabola and not the line, although they do coincide at that point. And then g of x is this parabola for 3 to 6 inclusive. Alright, so that's the setup. This is a typical, in recent years, typical type of problem where they give you a graph and they're going to have you do some calculus to the graph to see how well you can connect, what we've been learning analytically to what graphical interpretations we have for calculus. If f of 1 is equal to 3, what is the value of f of 5? This is another typical question, and this one screams fundamental theorem to us. So we're given a derivative and we're asked to find the value of the function at some point given the value of the function at some other point. So knowing that f of 1 is 3, find f of -5. So by the evaluation theorem or the fundamental theorem, depending on how you want to call it, the definite integral from -5 to 3, I'm sorry, -5 to 1, the 3 was the y value, f prime of x dx is going to be equal to f of 1 minus f of -5. So this is just the fundamental theorem. Now again, they gave us f of 1 as 3, so we know what to put here. The integral on this side over here, we can calculate that using geometry, the geometry of the picture, and so we could just rearrange this and solve for f of -5. So someone came into my room and I paused the recording. That was this morning. I'm picking this back up many hours later. And so I don't know exactly what the last thing I was saying was a moment ago on this video. But let's continue. So as I had mentioned at one point, f of 1 was given to us. We're solving for f of -5. And the integral is going to be solved by finding the net signed area bounded by the curve over here between -3 and 1. I'm sorry, -5 and 1. So I'm going to do a little bit of rearrangement before I get to that. So f of -5 is going to be f of 1 minus this integral from -5 to 1 of f prime of x dx, which is just g of x according to the picture. And so, again, f of 1 is 3, and let's go work on finding the value from the net signed area bounded by f prime between -5 and 1. So between -5 and 1, we have this portion under the horizontal axis, under the x-axis here, and then we're only going to 1, so then we have this triangle here. Remember, since some of this area is below the horizontal axis, we're going to count it as negative or subtract it from the area above. And so we can consider the area below as a trapezoid, or we can break it down into a rectangle. Going back for a moment, we can break it down into a rectangle and a triangle, and then add those two things together. So it doesn't really matter, your choice for the geometry of this. A couple things here. So if we did the rectangle and the triangle, we have 3 here by 3 for the rectangle, and then 1 by 3 for the triangle. I'm trying to squeeze it in there. It's kind of hard to see that mess. And then over here we have 1 by 2 for the other triangle that we're going to use. So let's go forward here and work this out. So f of negative 5 is going to be 3 minus, and we're going to work this out. So the area above is going to be, I'm trying to remember the numbers here, 1 times 2 divided by 2 for that triangle that's above, and then we're going to subtract the two regions that are below, and so we got the 3 by 3 rectangle plus the 1 by 3 triangle, so 1 times 3 divided by 2. And doing some arithmetic. Now technically, you don't need to do the arithmetic on the AP exam, so you could stop right there as long as what you write is clear and algebraically correct, meaning have plenty of parentheses in here. You don't need to go work out the details of this. So this is going to be 9 and minus 3 halves. And then the rest is just, my brain is starting to shut off a little bit for this, just because it doesn't want to do the arithmetic right now. But that's okay. So 1 minus 9 is negative 8. Negative 8 minus 11 halves, or minus 1.5 would be negative 9.5. And I'm getting 12.5. I hope I didn't make any calculation errors. I'm going to pause and double check my arithmetic. Yeah, I'm good with that arithmetic. So moving on, let's go on to part B. So let's go back to the question here. And I'm going to get some of this mess out of the way here so I can do what I need to do. Part B says to evaluate the definite integral from 1 to 6 of g of x. Now the thing they're doing here, or the skill they're checking with here, is to see if you can break this up, because we have two different things happening here. So from 1 to 6, so we're looking from 1, whoops, I got the wrong device here. So from 1 to 3, we have this rectangle. From 3 to 6, we have the parabola. And so they want you to demonstrate your knowledge of being able to separate this integral into two smaller integrals. So we're going to go from 1 to 6 of g of x dx. And so we're going to break this down into the integral from 1 to 3 of g of x dx, plus the integral from 3 to 6 of g of x dx. And as I was already suggesting, from 1 to 3 we have a rectangle. The height, I believe, was 2. I'll go double check that. And from 1 to 3 the width is 2, so this is a 2 by 2. So it turns out to be a square. And then from 3 to 6 we have the parabola, which I don't remember. I don't remember what the function was, so let me jump back here a few screens. 2 times 1 to x minus 4 squared, and everything looks pretty good there. So 2x minus 4 quantity squared dx. And so here we're, they want you to apply the fundamental theorem to this integral to find the, find an antiderivative. So I would do a little substitution for the expression in the parentheses, letting u equal x minus 4, and then du would just be equal to dx. And so this is essentially 2u squared dx that we're finding the antiderivative of from 3 to 6, or finding the integral of from 3 to 6. And so then when we do that, we're going to get 2/3 u cubed, or x minus 4 cubed. And I'm just mentally taking the derivative to make sure I'm not making any mistakes. And then we just got to evaluate that from 3 to 6. Notice the use of the brackets here. The 4 that we have in the beginning there is not evaluated on the interval from 3 to 6, so that's not included in the brackets. And so I'm probably going to do some of this math, some of this arithmetic mentally to squeeze it in here. If I plug in 6, and then I'm going to get 6 minus 4 cubed. 6 minus 4 is 2. 2 cubed is 8. 8 times 2/3 is 16/3. And then we're going to have to subtract here. And if I plug in 3, 3 minus 4 is negative 1. Negative 1 cubed is still negative 1, so it'll be minus a negative 2/3 or plus 2/3. And again, you don't have to simplify that. You do have to simplify this bracket expression with a 6 and the 3 on the outside, showing you understand that. You plug in and subtract. But you don't need to simplify this expression, even though I'm going to. 4 is 12/3 plus 16/3, that's 28/3, plus 2/3 is 30/3, so this should work out to be 10, which I will double check as I pause the video, just to make sure I didn't make any silly mistakes. Everything looks good with the calculations. Let's go back and take a look at what letter C is all about. It says on the interval, or for x between -5 and 6, excluding the endpoints, on what open intervals, if any, is the graph of f both increasing and concave up? So, well, increasing and concave up, what do we need to see in the graph of the derivative for f to be increasing? Well, we need to see f positive, okay? So, as we can see, we need to see the derivative positive, so f is increasing. So I need to see this graph here, f prime or g, positive. So that's on the open interval from 0 to 6. So I'm going to need this interval here, or rather some subset of that interval. Because I also need the graph to be concave up. Not this graph that I'm looking at, the graph of f. So how do I see concavity in this graph? I need to see where this graph is increasing. Where this graph is increasing, when f prime is increasing, that means f double prime is positive, which means f is going to be concave up. So from 0 to 6, where is this graph increasing? And it's increasing from 0 to 1 over here, and it's increasing from 4 to 6 over here. So those are the two intervals that we're looking for, because the derivative is positive and increasing, which means f is going to be increasing and concave up. So if we want to write that down, we would say f is increasing and concave up. Be careful with abbreviations on the AP exam, because they might not know what your abbreviations stand for. INCR is okay, but when we're doing CC up, CC down, they should get it, but I wouldn't risk it. You CC up on the intervals from 0 to 1. I'm going to use interval notation. The open interval from 0 to 1, and because it said open intervals in the question, so I'm going to leave them as open intervals. And interval from 4 to 6, because f prime, which is equal to g, is positive. And increasing on these intervals. So write a sentence, write a full sentence, make it as grammatically correct as you can. Don't worry about spelling so much, just make sure it's clear what you intend. Alright, now letter D. It says find the x-coordinate. So we only need an x-coordinate for this. We don't need to find the y-coordinate. Find the x-coordinate of each point of inflection on the graph of f. So how do I find a point of inflection? I need to see that the graph of f changes concavity. I'm looking at the derivative though, and so to see the graph of the derivative change, I need f to change concavity. So what do I need to see in the graph of the derivative to know that f changes concavity? Well, remember, I just said a moment ago, when the derivative is increasing, f is concave up, and when the derivative is decreasing, f is concave down. So where does this graph go from increasing to decreasing, or decreasing to increasing? That's what I'm looking for. So let's take a look. Right over here, the graph was decreasing and then increasing. And so therefore, on this part right here, the graph of f would be concave down. On this part right here, the graph of f would be concave up. And so there's got to be a point of inflection at x equals 4. Any other places where that occurs? Well, if you look at 1, just for example, just to show contrast, for 1 right here, the graph is increasing, but then it doesn't start decreasing right after that. So there's no change in concavity right there, because on the interval from 1 to 3, the graph of f is not concave up nor